Hello, George Romanic here. Welcome to Fundamentals of Weather and Climate playlist. What is a heating degree day? It's a simple measure of how cold a location is. It is also a measure of how much energy will be used to heat buildings. So more technically, heating degree days are a number of degrees Celsius that daily mean temperature is below 18 degrees Celsius. In other words, if the daily mean temperature drops below 18 degrees Celsius, then that difference is the number of degree days for that particular 24-hour period. So the first thing to quantify here is daily mean temperature, denoted as T over bar. It is simply calculated as the average of daily minimum and daily maximum temperatures. Now, from my video on daytime evolution of temperature, you know that minimum temperature during a 24-hour period usually happens to be right before sunrise, whereas the maximum temperature during a 24-hour period is usually observed around 4 p.m. local time. When we have this value, now heating degree days are calculated as 18 degrees Celsius minus this T mean. So as you can see, if the daily mean temperature is exactly 18 degrees Celsius, then that particular 24-hour period will have 0 heating degree days. But if the daily mean temperature is, let's say, 10 degrees Celsius, then 18 minus 10 is 8. That particular 24-hour period will have 8 degree days associated with that period. Now, how is this used? Well, as I said earlier, engineering and power utility companies use this measure as a rough estimate of how much energy will be used to heat indoor environments to 18 degrees Celsius. Now, this 18 degrees Celsius is an empirical measure that came from these engineering and power utility companies by monitoring power usage over many, many years and realizing that this seems to be a threshold below which people start using much more energy for heating. This equation is also only defined when daily mean temperature is below 18 degrees Celsius. If it is above 18 degrees Celsius, there is no need whatsoever for heating. Now you can immediately from here conclude that cooling degree days would be defined as T average minus 18 degrees Celsius. And cooling degree days are the number of degrees Celsius that the daily mean temperature is higher than 18 degrees Celsius. In high latitudes, like in Canada, heating degree days are much more important measure because we have cold climates. In lower latitudes, towards the subtropical and tropical regions, cooling degree days become more important metric for power utility companies because we have warmer climates and people use electrical power more for cooling rather than heating. Now let's see maps of calculated cooling and heating degree days for different regions. Behind me is a global map of mean cooling degree days on an annual basis. Clearly, very high latitudes effectively have 0 cooling degree days, and that is understandable because these are cold climates, so there is no need to additionally cool the buildings. But tropical and particularly subtropical regions where we have major deserts have many cooling degree days reaching 5,000. So a lot of electricity is therefore used to cool the buildings and lower the temperature to 18 degrees Celsius. If we now look at mean heating degree days, you can see that the situation is basically reversed. High latitudes have very large number of heating degree days, whereas tropical and subtropical regions effectively have 0 heating degree days. It is also noteworthy that these high latitudes have many more heating degree days, namely 16,000, than low latitudes had cooling degree days, namely 5,000, that we saw in my previous slide. And now, if we finally go to examine a particular country like Canada, where Environment and Climate Change Canada calculated the number of heating degree days and presented in this map. Now you can, I will explain, red colors in this map represent warmer environments and smaller number of heating degree days. And then as the colors are becoming colder, the climate is becoming colder, culminating with this blue color that indicates many heating degree days. What we can see here, something interesting, is that in Manitoba, Saskatchewan, parts of Ontario, Quebec, where we do not have some profound topographic features, these lines are pretty well behaved and follow latitude lines. But where we have tall mountains, like Rocky Mountains on the west coast, you can see that the lines of the constant number of heating degree days become a little bit irregular because topography plays such an important role on temperature. Another interesting feature that we can see on this map, and one of the features why these maps are used, is if we compare, for example, Vancouver in British Columbia and Montreal in Quebec, then approximately Vancouver has 3,000 heating degree days, whereas Montreal has approximately 6,000 heating degree days. That means if people in Montreal and people in Vancouver have the same electricity prices, then Montrealers will pay their electricity bill for heating 2 times more on annual basis than people in Vancouver, because they have 6,000 heating degree days, whereas people in Vancouver have 3,000 heating degree days. So if the price of electricity is the same, Montrealers will pay 2 times more for their electricity. Please make sure to like, leave a comment and subscribe, share this video, let's grow the channel, and until next video, goodbye.